Okay. All right, first things first today, we got absolute value. These are easy. I don't think you're going to have any issue with these. What do you know about absolute value? Anybody paying attention? What do we know about absolute value?
It's the distance of the number
Okay,
from 0
so the formal definition would be, it's how far I am from 0 on the number line. When I am working with absolute value though, what do I know about absolute value?
Maybe it turns positive.
It's always positive. Since it's a distance on the number line, it's always positive. So 6 plus 6, would you say 12? Now, when you do the next one, we treat the absolute value like parentheses. So in other words, we do what's in there first. Okay, so negative 3 plus 4 is 1, and the absolute value is 1. Okay, how about this one? 0, very good, because it's 5 minus 5, isn't it? So it's 0. How about this one? Do not even think about getting out your calculator. What are you going to do with that one?
Would it be like pi plus 4?
Wouldn't be pi plus 4. I want you to think about this for a second. On the number line, if I have a 4 and a 7, is the absolute value of 7 minus 4 the same as the absolute value of 4 minus 7?
Yeah.
Are those the same?
Yeah.
Aren't they the same? Now, if I take away the absolute value, they will not be the same, right? But as long as I have absolute value, the order that I subtract doesn't matter. So if you have pi minus 4 or 4 minus pi, as long as they're an absolute value, that's going to be the same number. Now, pi minus 4 will be negative something. Agreed? Because pi is 3 point whatever. But when I get this negative, it's exactly the same as the positive decimal I get if I subtract in the other order. Subtraction is commutative as long as you take the absolute value. All right, any question about that? You guys can all do this if you just slow down. Just slow down. Just 1 second. All right, now we're going to talk about distance. So what I need you to make a little note of right now is, when it says find AB, AB means the distance from A to B. So gone are the days when the teacher says find the distance. No, we're going to say find AB or PQ or LM, whatever. That notation, there's nothing above it, below it, around it. It just is an AB. That is your notation for distance. Now, does anybody remember how to find distance between coordinates? You know, you did this. Katie? Okay, you're on the right track. You're in the right group of stuff. Changing y over changing x is called slope, right? But distance is directly related to that. It's close to that. If I said radical, a big radical, would that ring any bells? The distance formula, yeah, that's right, the distance formula. To find distance, we're going to use the distance distance formula. Now, how does the distance formula work? Who remembers that? Okay, remember her change in y over change in x thing? To find the change in something, you subtract. So we're gonna subtract our x's, and I'm using this notation only because I have to somehow distinguish between my first x and my second x. I have two x's. So I'm gonna call one of them 0.1 and one of them 0.2. So I'm gonna subtract my x's, okay?
Square the x.
And you square it, absolutely. So we subtract them and square it. We do the same thing for the y's. We subtract them and square them. And then you remember what we do with these two? We add them. So if you can't remember that, I mean, that's like, oh, write down that formula. You have to know how to find distance. Now, I will never say, no teacher from now on will ever say write the distance formula. I don't care if you memorize the letters or if you just memorize the idea. The idea is you take x minus x and square it. So x minus x and square it. Then you take y minus y and square it. Keep track of your signs, your SIGNs. So x minus x squared, y minus y squared. Okay? Now we're going to add them together, and we're going to calculate that. So what's 3 minus 4? But when you square it, it becomes a positive 1. We're not going to have negatives under here, because we're squaring. 2 minus negative 1, 3 squared is 9. So our answer is the square root of 10. Now, sometimes when we do this, we don't get the square root of 10. Sometimes we get something like the square root of 12. Remember, if your radical simplifies, you need to do that. Square root of 10 does not, so we're done. That's the answer. Do you know what I'm talking about when I say simplify the square root of 12? We break it down like this. That look familiar? So that's 2 to 3. You have to do that to get full credit anytime you have a radical. All right. Would you try the second one on your own, letter B? It's exactly the same problem, except the points are different. And I would love to have a volunteer come up and do it for us. Not all at once. Volunteer. Okay, Alice.
What?
Don't know if I
Alice.
remember how to.
Sorry, I thought you were like, can't.
She's gonna volunteer.
I don't know if I remember how to
Okay.
simplify the
Okay,
radical
I'm
correctly
sure you
though.
do. And if you don't, we'll just laugh at you.
Okay.
I'm kidding, of course.
I know. Oh, wait. Oh! Yes. Thanks, Kara.
The rest of us, we never made a mistake like that, have we? Never.
The TBR.
Can you?
I do this little thing, but I don't know what does in
See?
72.
Well, you know, two dozen.
Oh, yeah. One.
Brilliant. Fine.
Oh, okay.
So you're done? Oh, no, no.
No.
You need
Oh.
2 twos to bring it
Right,
up.
right. Yeah.
So root 82 is the answer. All right, how about the rest of you? Did you get root 82? No questions about that, right? We need to know how the distance formula works. So you need to know you're going to subtract the x's, subtract the y's, square each one, add them up, and take the square root. Okay. Can't talk about distance without talking about midpoint. They kind of go together. They're used together in some problems. So now we're going to find the midpoint of these two. All right, who knows how to do this? Nick?
Isn't it x2 plus x1 over 2? And then like comma y1 plus y2 over 2?
That's exactly right. So if you are a formula type person and you want a formula, your midpoint formula is exactly what Meg just said. That's your midpoint formula. You add the x's and divide by 2, and you add the y's and divide by 2. Now again, nobody's going to ask you for a formula, you just got to know how it works. What do we call that when we add 2 things and divide by 2?
Average.
Finding the average. Midpoint is average. If you just remember that the middle value, the midpoint, is the average, you're all set. So average the x's. 3 and negative 2 is 1 divided by 2. I'm going to add them and divide by 2. Add them and divide by 2. What's my average y? 7 plus 11 is 18, divided by 2 is 9. Isn't that easy? Midpoint is average. In a few chapters, we're going to be graphing our trigonometric functions, sines and cosines, and you're going to have to find midpoints. It's easy. Average, average, average. All right, so try 5B on your own. Let's do 5B. Jake, you're just sitting there. You ever done?
Yeah.
Okay. What do you come up with? This is 5B. What did you say?
1, 2.
1 comma 2?
Yes, ma'am.
Nods? Shakes? Thumbs up? No questions. Everybody's got it. Midpoint is. All right, 6A. Find the area and perimeter. Find the area and perimeter of this thing. Okay, well, it's a triangle, obviously. What do you know about perimeter? What's perimeter mean? Huh?
It's the sum of both sides.
Exactly, it's a distance around. So to find the perimeter, what are we gonna have to do?
Find the distance of all.
So we're gonna have to find AB and BC AC and add them up?
Yeah.
So let's divide and conquer. We're gonna use the distance formula, would everybody agree?
Yeah.
So row 1 over there, then you guys, your whole row, you guys are doing AB. Okay? You guys are doing BC, and you guys are doing AC. We're all doing the distance formula, we'll just save some time by sharing the load. So tell me what you get. You're doing the distance formula, so quick reminder, if you've forgotten, that means you subtract the x's, subtract the y's, square those, add them up and take the square root. You done? You're not done? Almost done? What'd you get?
AB is radical 41.
Square root of 41? Anybody else agree over there in row 1? All right, anybody else got something?
I got radical 41.
You got square root of 41 also? So BC? Did you guys get the same thing? What did you guys get?
I got root 82.
Square root of 82. Now, I need it, before I get too far into the problem, are we in agreement, each row here? You guys good with the answers that were given? So, if I want the perimeter, that means distance around, I'm gonna add these up, right? So square root of 41 and square root of 41 would be 2 square root 41s, and I can't do anything with him except just tack him on. So that would be my perimeter.
Would you not be able to divide, like, or, never mind.
Go ahead.
Never mind, I realized the answer to my question.
Okay, I think what she maybe was gonna say is, does this simplify? And you can break it down, but it's 2 times 41, and then you can't break it down anymore. And remember, you have to have 2 of something before you can reduce your radical. So we're done, that's it, that's our perimeter. All right, what about area? How do we find area? Who remembers? This is a triangle. Who remembers how we find area? 1/2 base times height. Now, one of the coolest things, I mean, there's so much cool about Precal, but one of the coolest things is we learn how to find the area of every triangle. But right now, we can't do that. The only way we can find the area of a triangle is to have a base and a height. And that means that somewhere in this, I need a right angle. And luckily, we have it. Because if this is root 41, and this is root 41, and this is root 82, the Pythagorean Theorem works. Because if you square root 41, and you square root 41, and you add them together, don't you get root 82 squared? Because 41 plus 41 equals 82. And if the Pythagorean theorem works, it means you have a right angle. And if you have a right angle, you have a base and a height. So the area of this triangle is 1/2 root 41 times root 41. The base and the height are the 2 legs, not the hypotenuse, the 2 legs. They're the ones that make the 90-degree angle. Well, what's root 41 times root 41? 41. So our area is 41 over 41/2. Now again, that's only possible for us at this stage of the game, because that's a rigged problem. If we just made up 3 points, it would be a problem we'd have to do later on in the year. But you will be able to do it. No matter what the points are, you'll be able to find the area. All right, everybody good with that? A little bit tricky. Okay, how about B? Let's do the same thing with B. Let's divide and conquer again. Let me get them plotted here. So we have negative 2, 1. And negative 2, wait a minute. Negative 2, 6. Oh, this is gonna be easy. Why is this so easy? What are we noticing? Aren't they right on top of each other? Aren't the points lined up horizontally and vertically? So this is a rectangle. See how these two are, well, ignore my picture. These two are supposed to be right on top of each other. And so are these, and then these are straight across from each other. So I got a rectangle. All right, let's find the perimeter. So, AB, row 1 over there. You guys got AB. You guys got BC. You guys have CD. And I'll do AD. Now, what should happen? What better happen? We better get some matches, right? All right, let's see if we do. AD. They're actually straight across from each other or straight above each other, so you don't really need the distance formula, but you can use it. For AB, did you get 5?
Yeah.
For BC, did you get 6?
Yeah.
And for CD, did you get 5?
Yes.
So what's our perimeter?
22.
5 and 5 and 6 and 6, 22? It's a rectangle. How do we find the area for a rectangle? Base times height, length times width. Did you get 30? Ah, that was so easy. I thought that was going to be more fun than that. That was so easy. One more little geometry problem here. One more little geometry problem. Prove that the diagonals bisect each other. What is going on? Prove that the diagonals bisect each other.
Oh, okay.
Help. You have no idea. Okay, do you know what we mean by diagonals? Okay, so the diagonals, so would AC be a diagonal? And likewise, BD is a diagonal. Would you agree with that? Those are the diagonals? What does bisect mean?
Right in the middle.
Right in the middle, so cut in half, right? Right in the middle. So what you're trying to do is show me that these two, the red and the purple, cut each other in half. Okay, if they cut each other in half, look at the red line. What point would that be? That would be the midpoint. And if the purple one is also cut in half, wouldn't that also have to be the midpoint? So to prove these things bisect each other, Could we find the midpoint of red and the midpoint of purple and see if they match?
Yes.
Got it? Then do it. Do it. Midpoint of red. How do we find midpoint? Remember, midpoint is average. Average the X and the Y's. And if they have the same midpoint, they bisect each other. I got 2 for both midpoints. Prove that the diagonals of the figure bisect each other. They intersect at their respective midpoint, right? It's the same thing. They both have the same midpoint. All right, we're gonna crank through 8 and 9, hopefully, and then we'll be done for the day, I promise. So, here we go. Number 8. I don't know what you guys did last year, if you talked about circles. Did you talk about circles last year? No? So you didn't talk about how to write the equation of a circle, or what the equation of a circle looks like? All right, then we're gonna get a crash course in that. We're gonna start with this one right here. We're gonna start with the second one. It says, write the equation of the circle given the center and the radius. Now, you know what the center of the circle is, you know what the radius is. The equation of a circle, this circle right here, looks like this. They're really easy. X minus 5 squared, y plus 4 squared equals 36. So that's the answer. Now, how did I get that? What did I do to get the equation of that circle? First of all, this is what equations of circles look like. There's an x squared plus a y squared equal to a number. Now, look at this x and y squared quantities. X minus 5, y plus 4. Where did those come from? The center. And it's the opposite. So when that was a positive 5, when I wrote my equation, it's x minus 5. And then y plus 4. Okay. Now, this number over here, where do you think he came from?
The radius.
It's the radius squared. Now look, you have an x squared, you have a y squared, so this guy is going to be an r squared. So let's come up here to this one. If the center is at the origin, then won't these two numbers be 0? And we generally don't even write them. We just say x squared plus y squared. Now, if you want to write x minus 0 squared and y minus 0 squared, that's perfectly okay. Or plus, I don't care. We don't need to put the zeros in, but if you're more comfortable doing that, you can. And then what's this going to equal over here? 9, r squared. That number, this number that it equals, is r squared. All right, so see if you can do the last one. What's that going to look like? Take a minute, write down your guess. And then I'll do it too. Let's see. Emma Ayers, you feel brave? What do you think this is?
X minus 0 squared plus y minus 4 squared equals 25. Oh wait, no.
Common mistake, careful. You want to square the square root of 5. What happens when you
Oh, you just
square
get rid of
a radical? Won't that just be 5? Now, you can think of it as the square root of 25, but it's going to be 5.
Okay.
All right, I know that was a quick little run through there. We'll pick up there tomorrow. Whenever I see you again. And